Let us now learn about the circumcenter of a triangle. Circumcenter is the point of intersection of the perpendicular bisectors of the sides of the triangle. Now, what is meant by a perpendicular bisector? It is a line that is perpendicular to the side of the triangle and bisects it. Right? What is meant by bisects here? It divides the side into two equal parts. So a line that is perpendicular to the side of the triangle and it divides the side into two equal parts is known as the perpendicular bisector. So we can draw three perpendicular bisectors, one for each of the sides, and the point of intersection of all these three perpendicular bisectors becomes the circumcenter of the triangle. Let's understand this with the help of an illustration. So triangle ABC as usual here. Let us draw the perpendicular bisectors for each of the sides here. If you look at the side BC, we know that perpendicular bisector bisects the side. That means it divides the side into two equal parts. So let's say this is the point where it bisects, right? This is the midpoint of the side and it is perpendicular to the side. So it is perpendicular, means it makes an angle of 90 degrees. So this is one of the perpendicular bisectors. Likewise, for the remaining two sides also we can draw perpendicular bisectors. Let's draw for side AC, right? Let's say this is the midpoint. That is, this is the point where the perpendicular bisects passes through. Now let's draw a line which is perpendicular. So you know the angle here is 90 degrees. And the third perpendicular bisector here for the side AB, right? It may be taken as shown here. So the angle made here is 90 degrees. Right, so you see here that all the three perpendicular bisectors meet at a common point, which is the circumcenter of the triangle. Circumcenter is generally denoted by S, right? So circumcenter S of the triangle is the point of intersection of all the three perpendicular bisectors for the sides of the triangle. Now the interesting fact about circumcenter here is that the circumcenter is equidistant from all the three vertices. The circumcenter S is equidistant from A, B and C, which means the distance from A to S is equal to the distance from B to S is equal to the distance from C to S. And it is because of this reason that from this point, keeping it as a center of a circle, we can draw a circle which passes through all the three vertices, right? This can be considered as the center of a circle that circumscribes the triangle. What is meant by circumscribing the triangle? It passes through the three vertices of the triangle. And why does this happen? Because this is equidistant from all these 3 points. So it is obvious that all the 3 points lie on a single circle. And there is only one circumcircle that can be drawn for a triangle. So this is the center of a circle which passes through all the 3 vertices. So I'm just trying to draw a circle here. Let's say this is the circle. May not look like a circle, but let's understand the point there, right? So S is the center of a circle which passes through all 3 vertices, and this is known as the circle which circumscribes the triangle. The triangle is completely inside the circle and all its 3 vertices lie on the circle there. So that's about circumcenter, the point of intersection of the perpendicular bisectors of the sides. Now, what is circumradius? Circumradius is the distance from the vertex of the triangle to the circumcenter, right? This can be taken as radius. This is the center of the triangle. So center of the triangle to any of the vertex is known as circumradius, which is denoted by capital R. Likewise, SC is also the circumradius and SB is the circumradius. Okay, so we can say that the circumradius R is equal to the distance between the circumcenter and the vertex, so which can be taken as AS or BS or CS. All these 3 would be equal there. Now another important property with respect to circumcenter is that the angle made by any side with the circumcenter will be 2 times the angle of the opposite vertex, right? Like in case of orthocenter, we have seen that the angle made by any side with the orthocenter and the opposite angle are supplementary. But in case of circumcenter, the angle made by any side with the circumcenter is twice the opposite angle, which is angle A in this case. So if we say angle BSC, right, the angle made by the side BC with the circumcenter will be 2 times the angle A. Likewise, the angle CSA will be equal to 2 times the opposite angle, opposite vertical angle, right, which is angle B here, 2 times angle B. And the angle ASB will be equal to 2 times the angle C here. Now this is actually based on the properties of circle and a chord, right? You very well understand that the chord of a circle makes an angle theta at the center of the circle, and the angle made by the same chord on the other arc will be half of the angle made at the center of the circle. So based on that property we can conclude this for the circumcenter. So the angle made, this is like a chord. If you observe, BC is the chord for the circle, right? So the angle made by this chord at the center of the circle will be 2 times the angle made on the opposite arc, any point on the opposite arc. A can be taken as one of those points. So this is an important result which we need to remember, so that if a question is asked based on this, we can mark the answer without doing any calculations, right? For example, you know, the question may say that the angle A is equal to 30 degrees. The angle A is 30 degrees. Then what is the angle made by the side BC with the circumcenter? If this is 30, this should be 2 times of 30. It will be 60 degrees. Right? So an important property for circumcenter. And the next point here is about the position of circumcenter, right? The position of circumcenter changes based on the type of triangle, like we have seen in case of orthocenter. Now if the triangle is acute angle, then the circumcenter lies inside the triangle, right? If it is obtuse angle, then the circumcenter lies outside the triangle. And for a right angle triangle, the circumcenter S is the midpoint of hypotenuse. So let's understand, let's just put it on paper here quickly. For an acute angle triangle, the circumcenter S lies inside. For obtuse angle triangle, the circumcenter S lies outside the triangle, same as the orthocenter there. But for a right angle triangle, which is a special case here, right angled triangle, the circumcenter is the midpoint of hypotenuse. So it actually lies on the triangle and it is the midpoint of hypotenuse. Midpoint of the hypotenuse. Right? So if we consider a right angle triangle, let's say this is the right angle triangle, A, B, C, right? Right angle triangle, angle at A is 90 degrees, right? Right angle triangle. So what will be the circumcenter? It will be the midpoint of BC. Circumcenter S will be on this one. If it is equilateral, or if it is acute angle, the circumcenter will be inside. Obtuse angle, the circumcenter will be outside. Now again, the point to be noted here is, if this is a circumcenter, we can draw a circle which passes through the 3 vertices A, B, C with the center as S. Now if you want to find out the circumradius, what is the circumradius? The distance of the circumcenter from the vertex there. So SB can be taken as a circumradius R, or SC can also be taken as a circumradius, or SA. Right? But the interesting point here is, in case of a right angle triangle, since the circumcenter is the midpoint of hypotenuse, we can say that the circumradius R will be half of hypotenuse. Right? So that's again a special case here. For a right angle triangle, the circumradius R is half of the hypotenuse. So if the length of the hypotenuse, let's say, is 5 units, circumradius will be 2.5 units. If the length of the hypotenuse is let's say 13 units, then the circumradius R will be 6.5 units, and so on, since it is the midpoint of the hypotenuse. Okay, so let's also make a note of that. R for a right angle triangle, R is equal to half of hypotenuse. And also there is a special case of equilateral triangle. For an equilateral triangle where all the 3 sides are equal, the circumradius R will be equal to A by root 3. A by root 3 units, where A is the side of the triangle there, right? Equilateral triangle is the one where all the 3 sides are equal. So for an equilateral triangle, the circumradius R is equal to A by root 3, where A is the side of the triangle. So that's about circumcenter and its various properties.